Okay, here we have three questions to deal with. And for the first one, we have to solve and graph the absolute value of the quantity x minus 4 minus 3 equals 6. So this is the first one. And we've got the absolute value of x minus 4 minus 3 equals 6. Well, our first step is to isolate the absolute value. So we'll add 3 to both sides, and we get the absolute value of x minus 4 equals, and 3 minus 3 is 0, and 3 plus 6 is 9. Now, we have to dispense with those absolute value bars, so to do so, we've got to look at two cases. The case where x minus 4 is less than 0, and the case where x minus 4 is greater than or equal to 0. And in this case, we can dispense with the absolute value bars by replacing 9 with minus 9. In this case, we can simply dispense with the absolute value bar, so we get x minus 4 equals 9. Now, next step, we need to isolate x, so we'll add 4 to both sides. So 4 minus 4 is 0, and 4 minus 9 is negative 5. In this case, we'll add 4 to both sides, and 4 minus 4 is 0, and 4 plus 9 is 13. So the values of x that solve this are x equals negative 5, and also 13 will solve it. But now let's graph that. So we'll go to the number line, and we'll put a solid dot at x equals negative 5, and another solid dot at x equals 13, and we're done. Now let's move on to question 2. So for problem 2, we have to solve and graph this inequality, the absolute value of x plus 7 is greater than or equal to 9. Well, we have to do our two-case thing, and so we've got the case where x plus 7 is less than 0, and x plus 7 is greater than or equal to 0. And we need these cases because they enable us to dispense with the absolute value bars. So if x plus 7 is less than 0, then we can dispense with the absolute value bars if we, and I'm going to do it the long way, I'll put a negative here, put a negative in front of this, and greater than or equal to 9, and now we'll multiply both sides by a negative 1. When we do that, we get x plus 7 is less than or equal to negative 9. Anytime you multiply or divide through by a negative, you have to flip the inequality. Now we'll isolate x, so we'll subtract 7 from both sides, and 7 minus 7 is 0, and negative 9 minus 7 is negative 16. So we're done with that. Now, for this one, we can just drop the absolute value bars, since the quantity of x plus 7 in this case is greater than or equal to 0. And now we'll subtract 7 from both sides. Subtracting 7 from 7, we get 0. Subtracting 7 from 9, we get 2. Now, we will draw our graph, and here we are at x, and we've got a solid dot at negative 16, and a solid dot at 2, and x, all values less than negative 16 satisfy this, so we'll graph that side. All values greater than or equal to 2 satisfy this inequality. And so our solution in interval notation is negative infinity to negative 16. We'll put a bracket there because we can include 16 union with and 2 to infinity. And if we were going to do set builder notation, just in case this pops up, that would be the set x such that x is less than or equal to negative 16 or x is greater than or equal to 2. And we're done with. So for problem 3, we have to graph and label the intercepts of f of x equals negative 3x plus 6. And we also want to keep in mind that y equals f of x. So wherever we see an f of x, we could substitute a y, but since this is a function, we'll use function notation and call y f of x. Now we're going to need the intercepts, so we're going to need to find the x-intercept, and we're going to have to find the y-intercept. So let's do that right now. So ordered pairs. Now what's the y-coordinate for any point on the x-axis? Well, it's 0. So we're going to replace y with 0 and solve for x. Correspondingly, what's the x-coordinate for any point on the y-axis? Well, the x-coordinate is 0 for all points on the y-axis, so we're going to let x equal 0 and see what we get. Now back to this. We're going to set y equal to 0. That is, we're going to set f of x equal to 0. So, in other words, we've got a negative 3x plus 6 equals 0. So we'll subtract 6 from both sides, and we get negative 3x equals negative 6. Now we'll divide both sides by negative 3, and we get x equals 2. So then our x-intercept is at 2, 0. Now, to find the y-intercept, we let x be 0. In other words, we evaluate f of 0. So we'll replace x with parentheses, plus 6. And if I put a 0 here, I must put a 0 there. But negative 3 times 0 is 0, so this thing just equals 6. So our y-intercept is at 0, 6. Now we are ready to graph. So in this case, yes, we have f of 0 equals 6. Now we're ready to graph. And so we have a y-intercept at 0, 6, and an x-intercept at 2, 0. And we'll run a line through these points, and there's our graph, and we're done.